So good afternoon, everyone. My name is JoaoSilva. I work in Capgemini Engineering and for Floyd project, and I will show a bit an overview about the Floyd project. So basically, in terms of agenda for this presentation, I will show the project, the motivation and the project structure. The use case is defined by each partner, the integration lines between the work developed by the partners, and also the last topic, dissemination and exploitation. So regarding the entities involved, so we have Capgemini Engineering, the project leader, Altis Labs, Altis Labs, sister, research center, IT, Vortex Collab, and also with the support of Carnegie Mellon University. So moving on to the motivation that led to the project. So today or currently there is a big evolution in terms of autonomous features. And one of the main goals with that is to try to achieve autonomous driving concept. So this can bring several advantages. It can be the reduction of accidents resulting from human error, to be more accessible to a wide range of users, for fuel economy, improve fuel economy, and so on. There are some key drivers that can be used for this. So 5G networks, it's one of those. One of its subsets, which is ultra reliable and low latency communications, to be able to have very fast communications for autonomous driving, artificial intelligence as well. And at last, on autonomous driving applications to be able to assist the vehicle during its journey. So regarding the objectives in a very generic way, the first main goal is to improve mobility services and to accelerate integration of autonomous driving in our society. And to do that, we are focused in a specific case, which is vehicular platooning. And to do that, we aim to build an end-to-end solution that can support autonomous platoons for the advanced use cases. So in terms of work package structure, so we have below the first work package, so which is for coordination and management. On the left side, in the first stage of the project structure, work package number 2. So it's more focused for the overall system architecture, the requirements, scenario thinking, the definition of the use cases of each partner. In the second phase, we have the more technical work packages. So work package 3 and 4. The third one, it's more focused for network management and enhancements. So for example, for management and orchestration for V2X, edge computing, the support between public and private domains. Work package 4, it targets vehicle connectivity and applications. So more between the communication between the members of the platoon and also cooperative autonomous systems applications, for example. In work package 5, it's more for validation, demonstration, integration of all the solutions from the project. And in the last one, work package 6, it's more for dissemination, communication, and exploitation of the project. So in this diagram, it's a very, let's say, simple diagram with the use cases of the project. So we can see the public and private domain. In the bottom right part of the diagram, we can see the use case from Altis Labs, basically focused in the handover between public and non-public domains and 5G networks. Use case number 2 from Vortex regarding the safety and privacy of the communications between the platoon members. We have the use case number 3 from Sister regarding applications for the platoons, for example, for object detection. Use case number 4 from IT, which is focused in the offloading using Wi-Fi as well and unlicensed spectrum. And use case number 5 from Capgemini on top regarding platoon support using operation support systems to be able to adapt the network, dynamically adapt network, and improve also the performance of the network. So in this table, it's, let's say, a summary. It was in a later stage that were defined some integration lines between the partners and the individual work between the partners. So in the first integration line, it's regarding the public, non-public handover. where there was some joint work between partners. The second one, more regarding local cooperative awareness. So basically to have an increased awareness for vulnerable road users using, for example, roadside cameras and edge cloud computing as well. Integration line number 3, more for multipath and also offload data to using Wi-Fi. Integration line number 4, more in the metrics analytics and the use of MWR, for example, for metrics retrieving from the 5G core. And the last integration line, it's basically an extension of integration line number 2 with some add-ons regarding, for example, the edge host application and multipath as well. So in this diagram, it's a very simple and high-level diagram with the architecture of the project. So we can see on the left side with the blue color, the public domain. On the right side with the orange color, the private domain. And explaining very briefly, so we can see on the bottom right the user equipment, which can be the platoon leader in this case of the platoon. It can be connected to 5G base station or Wi-Fi access point. It can be using some application for autonomous driving assistance in the edge cloud for latency purposes, the 5G core functionalities, and also management and orchestration components. So moving on to the next slide, there are a few numbers regarding dissemination and exploitation of the projects. So regarding publications, so far it were made 24 publications in international conferences. There are several students working for the project, where there are 8 PhDs, 11 master degrees, and also 7 bachelor degrees. A logo, a poster, a brochure were designed for the project, and the advisory board is composed by Luís Simões and Visabeira.